Lesson 30, AP Euro Scientific Revolution. Okay, in the 16th and 17th century, there's going to be a sweeping new view of the universe. The sun will become, in a sense, just another star. Although, I mean, that's what your textbook says, but it takes quite a while for this to kind of be the thinking that everyone has. And we'll get into that, especially because some of these guys are inspired by Neoplatonism. There's going to be a profound rethinking of morality, religion, and science as a result of these discoveries that they're going to have. New scientific methods and ideas called natural philosophy, which we'll later call just science, will challenge scholasticism and Aristotle. So remember, Renaissance ideas challenged scholasticism and Aristotelianism. The Reformation challenged Aristotelianism and scholasticism. And here we go again. Now, there are new devices that are going to have a sweeping effect on how we view our world. The telescope and the microscope. And, the book talks about these other challenges to tradition besides the scientific revolution, the Reformation, also the discovery of the New World. The discovery of the New World is going to really challenge things because, well, they're going to discover stuff that the ancients didn't know about. And remember, for a long time, people trusted the ancients' authority on all matters. Well, the ancients, if they were so smart, why didn't they know about North and South America, Australia? Why didn't they know about koalas and kangaroos and big old grizzly bears, the style that they come in North America? So here we go. The scientific revolution will establish this new view of the universe. This new view, though, will be influenced by a re-examination of past ideas. In fact, some of those past ideas will influence new ideas in a positive sense. In other words, they'll borrow some of those ideas. This revolution is a revolution that will spread very slowly. It's not some sort of immediate change. It takes a long time for a lot of people to realize about these scientific discoveries and realize the impact of these scientific discoveries. Artisans will be the ones who build these instruments that will be used to experiment by the natural philosophers, or as we'll call them later on, say in the 18th century, scientists. And these natural philosophers will work in universities, in royal courts, in their own homes, and eventually in these largely informal societies and academies of science that will appear. At the close of the 17th century, this new scientific method will be the standard for assessing truth. From the early 17th century through the 20th century, science will have become the greatest cultural authority of intellectual activity, which will be a defining characteristic of the modern West. And this scientific revolution that we're going to be talking about will begin with astronomy. Nicolaus Copernicus will reject an Earth-centered universe. He's a Polish priest and astronomer. He was educated in Krakow, which is a city in Poland, and in Italy. And in 1543 he's going to die, and that's when his book on the revolution of the heavenly spheres will be published. He'll challenge the idea that the Earth is the center of the universe, and his real purpose in this was to basically help the papacy improve the calendar, make it more accurate. So he's trying to come up with a way to make the calendar more accurate, and, well, we'll see what happens. So before we get into that, let's look at the system that he's challenging, the Ptolemaic system. Ptolemy's Almagest is a book that was the standard explanation of astronomy up to the time of this Copernican or scientific revolution. It combined Ptolemy's mathematics with Aristotle's cosmology. And commentators, the people who grabbed the Almagest and rewrote it and discussed it and came up with their own ideas, assumed that the Earth was the center of the universe. And here we see a picture showing the complicated orbits that the planets and the stars and the sun would have to make if the Earth was the center of the universe. See, the point is that under this system, the Earth is in the center of concentric crystalline spheres. which contain the moon, planets, the sun, and stars, and the outermost sphere is heaven, as depicted in this chart here. It was believed by Aristotle and a bunch of other people at the time that the state of rest was natural, that if you leave something to its own devices, it will just stop. So movement had to be explained by these crystal spheres oscillating or rotating around the Earth. The problem, retrograde movement. Planets seem to move backwards sometimes, so they had to come up with some sort of explanation, and this was epicycles. So on the spheres, these crystal spheres, there are little spheres that move on the crystal spheres, and this will work well enough. Here you see a depiction of the Earth in these crystal spheres, and you see a little circle on a circle. That's an epicycle. So that would explain why sometimes it looks like the planets are moving backward. Now, Copernicus is a sun-centered universe. He's inspired by Neoplatonism. In Plato, the sun was some sort of really special, awesome thing, kind of the source of creation and divinity. Now, Copernicus didn't come up with our modern conception of the universe. He kept epicycles. He had the sun as the center, not of a solar system, but the entire universe. So it's not completely revolutionary. Now, his system, though, meant that retrograde movement, this appearance of planets moving backwards, was now explained simply as an optical illusion. Since the Earth is also moving around the sun, there will be times when their relative motion will make one look like the other, look like it's moving backward from the other planets' position. Since we're only on Earth, we get to see the other planets look like they're going backwards. This is easier to determine the order of planets. The major impact, though, is really that Copernicus creates a discussion about whether or not the Ptolemaic system, the solution to the Ptolemaic system, is this Earth-centered universe. And it's going to take over a century for this to really catch on. Only a minority of thinkers will embrace Copernicanism. So here we see that chart in more detail. See in the center the Sun, and then there's Mercury and Venus, and then the Earth, and so on. Notice that last one, this orb of stars fixed infinitely, extend itself in altitude spherically, and therefore. Alright, so kind of the heavens. Okay, so this guy, Tycho, I guess, Tycho Brahe, and Johannes Kepler will make new scientific observations. Now, Tycho is a Dane, and he preferred the idea that the Earth was the center of the universe. He suggested his idea was to say that Mercury and Venus orbited the Sun, but everything else orbited the Earth. And he built a state-of-the-art observatory and collected scads of astronomical data to prove his position. Yeah, the funny thing, of course, is that his information is going to be used by Johann Kepler to prove the reverse. Tycho's an interesting guy. He loses his nose either to a duel or to syphilis, depending on who you talk to. Apparently, he liked to have decorate what used to be his nose with kind of a fake nose made of either silver or gold or copper, depending on the occasion. Anyway, here comes Johann Kepler. He's a German. He's the assistant to Tycho, and he's convinced Copernican ideas will work, but his universe is even more heliocentric. He's influenced by Renaissance Neoplatonism, which you can see here. Remember the Platonic solids, the cube, the pyramid, this idea that reality, true reality, are these abstract concepts because they don't change, even though matter changes. Okay, so this is a depiction of his kind of focusing on this and the idea of the sun being really important. He's going to use Tycho's data to figure out circles and epicycles won't work, and then he'll realize that elliptical movement with the sun at the center will explain things a lot better. And so he writes in 1609, New Astronomy. Think about this. This is about the same time as Shakespeare's doing his thing. So try to kind of put this in perspective of the other things going on during this time period. Now, a problem that he couldn't address was, why was planetary motion orbital, and why was it elliptical? So he doesn't really have an explanation for this. So now we get to, of course, Tycho and Johann didn't have an explanation for this problem of orbits and so on. Now we get to Galileo Galilei, who will argue for a universe of mathematical laws. In 1609, he's going to use a telescope. Now, remember when, Kepler is going to produce his groundbreaking argument for elliptical orbits? This about the same time Galileo is using a telescope which had recently been invented in the Netherlands. He's going to look up and see new stars and moons, mountains on the moon, which was supposed to be some sort of heavenly sphere that was perfect and perfectly shiny and all this kind of stuff. And you see spots on the sun, so things up there aren't perfect. This is something that the ancients were wrong about. He can prove that with a telescope. And he makes a Copernican argument in Starry Messenger and also in his work Letters on Sunspots. In 1610, he's working for the Grand Duke of Tuscany, a Medici. In this picture, you see him showing the Doge, essentially, things through the telescope. He will name Jupiter's moons after the Medicis, and the reason he's going to gain the attention of the church is not only because of his ideas, but also because he has a certain flair for kind of, popularizing his position as much as he possibly can. He goes out of his way to be kind of critical of the church on certain ideas about astronomy. So now that he has mathematical arguments, he believed in a rational universe subject to mathematical laws, that math would eventually could be used to even describe social relations. It is going to be something that's going to come along over time. So this new idea of math being really important kind of falls in from Neoplatonism, of course, and the idea that nature is cold, rational, mathematical, mechanistic, that means machine-like. So he's going to use mathematical arguments, which for many is going to be more persuasive than the telescope, because after all, who's going to trust a piece of technology they haven't personally used themselves? So the next guy in this list, so we've had Copernicus and Tycho and Kepler and Galileo. Now we get to Newton. Isaac Newton will discover the law of gravitation. 17th century scientists did not have a theory of movement that explained elliptical orbits, but in 1687 Newton will produce Principia Mathematica. He will be influenced by Galileo's math and the belief that inertia applied to resting and moving bodies. So inertia is kind of like momentum. Things that are moving will just keep on moving until they face some sort of resistance. So Newton believed objects move through something called mutual attraction, or gravity. Gravity will explain why planets move in an orderly fashion. And gravity is going to be stronger. He's going to argue that gravity is stronger the closer objects are to one another, and he'll prove this using math. But he doesn't explain the nature of gravity itself. He has no explanation for that. He just kind of can explain what it does. And here we see the famous apple tree that he supposedly sat underneath and got hit by an apple when he came up with his idea. So he's a mathematical genius, but he's going to use evidence and observation and experimentation. So he's going to like Francis Bacon's ideas, not so much Descartes. He thought Descartes' ideas about how to come to truth, how to come to a proper conclusion, would lead to too many errors. And the acceptance of Isaac Newton for Bacon's ideas will increase Bacon's popularity in the future.